This video shows you that a so-called self-financed wealth portfolio W is a martingale. Now that's rather technical, but it's really useful for follow-up videos. So you basically learn two things from that video. First, you see the definition of a self-financed wealth portfolio. And second, you also see what it implies if that self-financed wealth portfolio is a martingale. Now that is really important to later understand the difference between physical and risk-neutral pricing. Now, a self-financed wealth process, capital W, is a martingale if the following condition holds. Now suppose you can invest a fraction pi of your wealth into the vector of risky assets S. And you can invest 1 minus 1 transpose pi into the locally risk-free asset. Now the resulting wealth process is called self-financed if it solves the following E to SDE. It says that the wealth is only changing because of your investment decision, meaning it's going to grow in expectation with 1 minus 1 prime pi RT dt, that's from your risk-free investment, and then pi fraction of your wealth is invested into the risky instrument, which gives you the return ds over s. Now, as ds over s, the return of the risky assets, can be written as mu t dt plus sigma t dbt. We rewrite the last SDE for the wealth process as follows. So now we want to show that the self-financing portfolio W is a martingale. So as an exercise, I want you to verify that the change of m times W divided by m times W equals with 0 dt plus pi t sigma t minus lambda t dbt. Now that tells you that m times W is a local martingale because its conditional expected change is 0. So the martingale property for W implies now the following key relationship. Now it says that W in T is simply the conditional expected value of future W's times a discount factor. And the discount factor relates to the change in the SDF between today and the future. So in other words, that relationship says that today's wealth equals the expected discounted value of future self-financed wealth. And if you look at that relationship, you might know that comes extremely close to a pricing equation, which says that the price of an instrument is the expected future cash flow times the discount rate. But more on that on a follow-up video.